I hope you enjoyed that last case study. We've got another one for you now, would you believe? And this is Ireland's first commercial office certified to the Passive House standard. And Mosart were the architects for this. So I'm presenting this with some small degree of pride, being able to show you this. And it's actually in my hometown in County Wexford in the southeast of Ireland as well. So it's got a kind of a personal appeal to me as well. So let's jump in. Now this is a project under construction, an aerial view obviously. It's about 5,000 square metres or maybe 50,000 square feet, 4 stories. And what's quite unusual actually about this building is we've got a low carbon timber enclosure, right? So the timber, the skin of this building, if you like, what you're seeing here in black is actually timber frame, or in the States we would say wood frame, which is very unusual. And it took a bit of negotiation with the local fire officer working with the county council, but we got that over the line. And our motivation for that was to have a passive house which was also, you know, as low embodied carbon as we could make it. It's certainly not perfect. There's a lot of steel, a lot of concrete, but it was our kind of measure to try and go low embodied carbon if we could. And the insulation in that external wall is cellulose insulation, which is made from recycled newspapers. You know, we're a big fan of that. And the windows were actually made locally as well by Rainiers. The windows actually were made about 5 kilometres away. So kind of a really interesting case study. But just to remind ourselves now, we're here to talk about windows. So let's have a look at that. Okay, let's look a bit closer now at the facade. So you can see here, these panels were made in a factory, and that black membrane that we're talking about there is what we call the weather defense layer. Sometimes it's called a breather membrane, and it's waterproof, but it's wind tight. And so it's waterproof, wind tight, but vapor open. How about that? So if any vapor manages to leak into the assembly in the winter time, there's a vapor drive from inside to outside. So basically the vapor is trying to escape out through the wall, and it's very important that whatever membrane you have on the outside of your timber wall is vapor open. So I'm going to say that again. That's amazing, isn't it? So it's wind tight, it's waterproof, but it's vapor open. What an amazing product. And you can see then the big holes for the windows, which we're going to look at in a second. You're really lucky, guys. Today we actually have a cross section of the wall, and I want to go through the various elements with you now. We've got the kind of an exterior view on the left, and we've got an interior view on the right. So let's have a look at the different materials. So as I mentioned, the wall is insulated with cellulose. We've talked about that quite a lot, and we don't have a solid stud in the wall. We actually use a TJI beam. It's kind of like a steel beam but made of wood, right? And the advantage of that is it really reduces the thermal bridge effect through the wall. And because you've less wood, because of the shape of that stud, you've actually less wood, and therefore you have more insulation. So it basically improves the U value and reduces the thermal bridging. Now on the outside, on the exterior of the TJI beams, we have a racking board, and it's called a medite vent. So it's a sheathing board, but it's completely vapor open. And on the outside of that, again, we have this vapor open weather defense layer we talked about, and you've got your rain screen on the outside. So whatever, I won't dwell too much on that. And then on the inside, this green board is the board that we're using for airtightness. You would have seen that in the airtightness and vapor control module. So on this project, we didn't use a membrane for airtightness and vapor control. We used that OSB board, that Smart Ply OSB board. And then finally, you know, for fire lining and so forth, we've got a plaster board on the inside. So that gives you a kind of a fairly good cross section. And you can see the window, by the way. We're simulating a window in the middle of the wall there. So let's have a look and see how we did that in a little bit more detail. So we have a detailed construction drawing here now, a plan view. You can see the window towards the left. You can see the TJI beam. We've got our weather defense layer, which is that black membrane on the outside, which is vapor open. And then we've got our cellulose insulation. And on the inside, we have the airtightness and vapor control layer, the AVCL, airtightness and vapor control layer. And in this case, it's created by that green OSB board. If we zoom in a little bit closer, of course, everything has to be taped to the windows, and we're here really to talk about windows. So we've got just a small little detail between the TJI beam and the window reveal. There's a small little pocket there, isn't there, that has to be insulated. And it would be very difficult, to be actually almost impossible to get cellulose insulation there, because cellulose is like, it's like dust nearly, it's like feathers. and it just wouldn't kind of remain in place. So we actually put a wedge of wood fibre insulation there, kind of semi-rigid, stays in place. So again, and low embodied carbon, really, really pleased about that. So the red tape that we're seeing on the outside, it's not actually red in reality, but we use a special tape on the outside to connect the window frame to the weather defense layer. And then represented in green here, we have another tape on the inside, which we'll show you in a second, where we tape the window frame to the internal OSB board, right? So we're basically using a tape on the outside to connect to the weather defense layer, and a tape on the inside to connect to the AVCL. We did a thermal bridge analysis on this detail, by the way, and we're quite pleased with the overall psi value. You can see the psi value there, 0.058. It could be better, to be honest. I mean, if we surrounded the whole rough opening with insulation, we could have improved that psi value a little bit. If we put insulation up against the frame, either on the outside or on the inside, we could have improved the psi value a little bit. But it's a very, very simple detail. It's not fantastic with regards to thermal bridge coefficient, but there's no condensation risk. You can see the FRSI there. Once the FRSI is above 0.7 in our climate, there's no risk of condensation. So it's safe from a condensation point of view. It's affordable, buildable, and you know, the psi value, the thermal bridge coefficient is not too bad. It's not great, but it's not too bad. And again, I'm not at all reluctant to share that with you, because, you know, no building is perfect, you know, and if you chase perfection all the time, you'll run out of money, you'll run out of time, and the whole thing will become hugely complex. So let's have a look now of the window where it has been installed in the wall. And so the black aluminium frame on the right hand side, that's our window, that's the Rainier's window. The green board is our airtightness board. The black tape there, by the way, is where we've actually taped up all the joints for the various boards, so I think that makes sense. What I want you to see here basically is the white tape that we've used to tape the window to the reveal. And look especially at where there's some brackets here. You can see there's a window bracket on the vertical, on the jamb, and also on the horizontal. And we had to put an extra bit of tape there, an extra bit of airtightness tape in those places, just to make sure that we had the end of the bracket covered. Because, you know, when you run a tape along and it has to bump over a metal bracket, obviously, you know, there could be a compromise there in terms of airtightness. So we left nothing to chance there. We covered absolutely everything. What does it look like from the outside? You can see now our weather defense layer with the black membrane. The window is now in position. You can see that hopefully. And now you're actually seeing the vertical and horizontal rails on which we put the external cement boards for the rain screen. So hopefully that gives you a good sense of how we've installed these passive house windows in this certified passive house office building. On this project, there's 955 square meters of windows. And even though the windows are really good in terms of U value, they're the weakest part of the envelope. So we've got to concentrate really very clearly on window placement, connection to the airtight layer, drainage, and all of that kind of thing. So we're going to have a quick introductory look at this now. This is our airtight insulated thermal envelope here, and we're looking at a window opening. Now, ideally, we're going to place the window somewhat in the middle of this opening. If it's very far out, you have more solar gains. If it's very far in, you have less solar gains. So we have to model all of that in the software to find the optimal position. So that's an existing opening. If you come over here now, you'll see we've installed a window here. The glass is yet to be installed in this, obviously, but you can start to see here now the process. We've got these straps here. Triple glazed windows, very heavy, a lot of weight there, so it's got to be strapped in very, very securely. And you can see also here these shims, because we've got to make sure that the window is inserted plumb, so it's plumb this way, and it's also, everything is sort of lined up very nicely. There's going to be a little gap here, a little tolerance of maybe 5 or 6 millimeters here. We're going to put some insulation in there, and then we're going to make an airtight connection there as well. So we're going to show you how to do the airtight connection in a few moments. It's really windy and cold here today, and you can really appreciate the importance then of airtightness and stopping that cold air infiltration. We've got our windows here. The glass isn't in yet, but what we're looking at here specifically is the airtight connection to the envelope. These green boards here, this is a smart ply. That's the opaque envelope, which is obviously very airtight. So we've got to make a very good connection now between window frame and our airtight wall. We're using this airtight tape here. We're coming up only a little bit on the window frame, maybe 10 or 12 millimeters. You don't come up too far on the window frame, because otherwise then the tape might be exposed afterwards. So you definitely don't want to see the tape. One little quality assurance issue here. You can see where my finger is. There's a metal bracket here which is keeping the window in place, and we're being very fussy on airtightness there. We want to actually go back over now and put some additional tape over that bracket so that we don't have any micro little holes there for air leakage. So we're really down to that level of airtightness. And just in the corner here, you can see it's very important that we don't have any rounding of the airtight tape at that junction. If there was a rounding of the tape there and somebody comes in to put a window board, you could shear the tape at that location and have an air leakage. So all of these things are terribly important when we're talking about passive house levels of airtightness. So it's great to see this underway now here today. The outside now clearly, and on the outside we want to think about wind tightness. Inside is for air tightness, outside is for wind tightness generally, and it's extremely windy here today. So we've got our window frames here, and we want to make a wind tight connection between the window frame and our breather membrane on the outside. This is wind tight but vapor open, more of that later. And this is a wind tight connection here. Again, we don't want to come too far on the window frame here, and we've got to make sure that there's no rounding in any corners, because if there's any rounding, it's going to get shorn later on some way in the process. We're also using the same tape down here as a sort of a flashing. So we've got the weep holes here. These are the weep holes here for the aluminium window system in case there's any moisture build up inside in the frame. But it's very important then that moisture is brought away if there is any risk of moisture in the window frame. So it's all connected up here and it's all beautifully well sealed up. And then if you come a little bit further down here, we're at another stage here where we're starting to see now the flashing going in. So this is the flashing system here. So the bulk water, the rainwater will run down here, hit this windowsill, this pressed metal windowsill, and run off the facade of the building. So wind tightness is really important, and we're on a very exposed site. We're in a river valley here, and we don't want to lose any heat loss through lack of wind tightness and lack of air tightness. So I'm really quite happy with what I'm seeing here on site today.